And feel free, so kind of put stuff in the chat, whatever, if you want me to talk about anything in particular. So, okay. So here's project 1. So I'm going to start from the beginning. So I imagine that some of you maybe haven't started the project, so that might be useful. And I'm going to talk through as much as I can. So basically what we're trying to do, so I'll start with the sample inputs. So this is cities and this is Wiktionary. So what we're trying to do is we're trying to give a starting string. So for example, TOR. This is, so there was a Toronto somewhere. So let's say like TORO. And what we want is we want to find all the terms that start with a given start. So for example, TORO. And then we want to display, and then we want to sort them by the weight. So in this particular file, the weights are already sorted, but in general, that might not be the case, right? So the way we set things up is we define the struct. So the struct here, there is something in the chat. Yeah, so same link. So 415, not 4. All right. And I'll try to answer questions if there's time now as well. So what we're doing is we basically have this struct for terms. So here we have a fixed array of length 200, and we have a double weight. So one thing to pay attention to is this is a double, not an int, not anything like that. So you save it as so when you display it in particular, that's a double, so that's %f. And sorry, so what we're going to do is we're going to read in the entire file. So the entire file is going to be an array of these kinds of structs, right? So let me open VS Code again. So that means that you'd have something like, so I'm writing it kind of like in Python notation, right? But it's going to be like TORA, whatever. And then you also have a weight. And then that would be a struct. And then you would also have whatever, Vancouver. And then you'll also have Toronto. Something like that, right? So that is kind of the picture of what you'll have. So the specific syntax is not like well, this is not exactly Python either, but the specific syntax would be that each of those guys is actually a struct, right? So specifically, the name of this, so the name of the struct here is just term, right? So specifically what you'll have is something like this. So you'll have like term, or terms, and that you would have to malloc with the appropriate amount of space. So like enough space to store m terms. So then you can access term number 1 using something like r term 0, right? So r term 0 would be the 0th term, so it would be this guy. The type of r term 0 is just term, right? So in the same way that if you have something like int star array. And then like array is malloc, and then like size of int 10 or something, then you can do like array at 5, and that is an int. So in the same way, this is a term. So term, to remind you, let me copy this quickly. So term looks like this. So this means that if you say something like our term 0.weight, that would be the weight of term 0. Right? So this, by the way, is going to be potentially different inside the function, right? So if what you're doing is you're sending R terms to a function and you want to be able to modify R terms, then what you'll do is you'll do a pointer to R terms. So the recording is going on YouTube in the same way that the lectures are going on YouTube. So that would be like this, and you would say PR terms is this. So that's because if you're sending in the address of R terms to create R terms, so this would look kind of like this. Then in order to get the R terms, you would do star PR terms. Does this make sense to everyone? There's questions. So, okay. So is it star or is it not star? Well, it depends on the situation. So here we send in the address of R terms. So assuming that R terms is of type term star. So that means that in here, PR terms is of type term star star. And that means that to access the original R terms, you would say star PR terms. So in order to access the weight, what you would do is something like this. So this is really important because this is something that the compiler will not necessarily catch. So in the same way that here you would say R term 0.weight, here you would say star PR terms, which is the same as R terms, and then add 0.weight. So what you shouldn't do is say PR terms at 0 arrow weight. Well, for 0, it would work. For 5, it would be a problem. The reason is kind of subtle. So PR terms is not the same as R terms, right? PR terms is the address of R terms. So saying PR terms at 5, that's saying advance 5 slots starting from PR terms, and then treat it as an R term. But that's not correct because there are not really slots starting at PR terms. There are slots starting at star PR terms, which is the same as slots that start with R terms. Is that making sense? So another way of putting it is, what is this guy equivalent to? Well, it's equivalent to star PR terms plus 5. So that's the same as PR terms 5, right? And then arrow weight, that's saying star that, and then do dot weight. That's not the same as saying star PR terms plus 5, and then star that. And then do dot weight. So the difference is between advancing 5 slots from star PR terms versus advancing 5 slots from PR terms. So star PR terms and PR terms are 2 different addresses. Does that make sense? Questions? So, okay. So the reason I bring this up is because C is going to compile both of those things. And C is going to compile both of those things because, well, like the two stars on the left-hand side, they do cancel out those stars. So you're allowed to say dot weight. It's just that it happens that this doesn't actually make sense. On the other hand, this does make sense. So something to pay attention to when you're doing read-in terms. All right. So the job eventually is to do autocomplete. So the way you would do autocomplete is you would figure out you would first sort alphabetically. So you have this kind of deal, and you first want to sort it alphabetically so that you know that. So this would go like this. And then if I sort this alphabetically, so V comes after T, so it would look like this. Once you sort it alphabetically, in this example, if you're matching T, O, or O, you would say, okay, so those are the terms that I want to actually capture. And then once those are the terms that you captured, you say, okay, now I want to sort by weight. Right. So if you match T, O, or O, then eventually you want to sort by weight. So those guys are going to be rearranged. So at this point, autocomplete should create another block of answers and copy this part to the answer. In fact, like it's better to copy this part to the answer directly without modifying the original. Okay, is that making sense? So the only thing that's left is how do you sort? So the sorting is done using qsort. And part of your job is to kind of work a little bit to figure out how qsort works, but there is a tutorial. So here's an example from the tutorial of how you sort integers. Right. So what's going on here is we're saying, okay, so here's the block of values, and there's 5 values in there, and each value is of size of integer, right? So here the block of values is whatever, 88, 56, 102, and so on. So each of those is an integer because it says over here. So here we're saying we're going to have 5 values, and each of those is an integer. And then we supply a custom comparator function. So the job of the comparator function is to take pointers to 2 elements. So for example, a pointer to here and a pointer to here, and to return a positive number if the first argument is larger, and to return a negative number if the second argument is larger. So the way this is accomplished is you're saying, well, like in this case, we're just comparing integers. So we'll just say, compute the value at A. So here you get the pointer to, for example, 56. So you say it's an integer. So I'll convert it to an integer, and then I'll go and get the value of that integer. So if you're comparing, for example, 56 and 2, then A would be a pointer to the 56, and you're going to that pointer. So the value of this is going to be the 56, and the value of this is going to be the 2. And then because 56 is larger than 2, you'll return 1. So, you'll return a positive number. So the point of the comparator function is you can make it anything, right? So you can, for example, say, I want to sort in reverse order. So what you can do is, instead of returning a positive number when star A is larger than star B, instead you'll return a negative number. how can we accomplish it? Well, we can just switch those guys. So now if A is larger, you'll return a negative number. And if A is smaller, you'll return a positive number. So what that would do is it would sort values in reverse order. So in this case, those are integers. But if this is a struct, you can also say, well, I want to access the weight at B, the weight at A, or I want to access the string at B, the string at A, right? So you can do anything there. So that's kind of my overview. Yeah, I'm happy to take questions for about 15 minutes now, if you have any questions. How to extract the terms that match the query string. So you don't exactly, so kind of how do you extract? Let's do an example. So let's say that I have my values here, and I want to extract integers. So I'll get the values, and I'll get low, and I'll get high, and I'll get results. So what can I do here? So let me just pull this. So what can I do here? So I can say, okay, so I'll create the result. So this is not exactly what I want. So I'll create the result, and initially, so this is not necessarily what you need to do for the project. This is just for the sake of the example. So I'm creating a block where I'll store the result. And what I want is I want put values that fall between low and high into result. So, okay, so I'll have my I, and that would be the index in values. And I'll have my result I, so that would be index in result. And I'll just do this, right? So I'm saying if values is great between low and high, so we'll express it like that. So just not to be fancy, I'll move the result I plus plus over here. So if I want to copy it, I'll just copy it into index result I, and I'll increment index result I. So now if I want to be kind of economical about it, I'll say, okay, so now that that's done, I know that maybe I didn't need this many in results, so I'll like reallocate or something. So I'll say result is realloc, and I just reallocate to have this much space. So result I spots. So that's one example of how you would extract something to a new array. So if I want to call it, I'll define values. Sure. And then I'll do like extract ints. So I'll say values, sure, between 30 and then 60. And then I want to put, and the number of values is 5, and I want to put stuff in result. So it might be nicer to name this P result. So that's actually Copilot screwed up a little bit. right? So here, result starts out as the address of nothing in particular. And then here, I initially make result be a block of memory of this size. And the way I make result be that is I make star p result be that, right? Because p result is the address of result. So going star p result is the same as going result over here. Right, so that's an example. So let me see what the questions are. That's right. Sorry. So does the txt file have /n delimiters? Yes, it does. Each line has a /n at the end. That's why they're displayed as separate lines. How to deal with them? Well, it's like a little bit up to you how you deal with it. So one thing you can do is you can just read the file in line by line using fgetS, which is like the job of fgetS is to do that. All non-Latin characters in city.txt were automatically converted to Latin characters. Yes, that's fine. Don't worry about the encoding.
Wait, just a follow-up question. So fgetS removes the /n, right?
Yes.
Okay, that's good.
Well, I think so, at least. Yeah. But anyway, like the format of the file is going to be the same as the format that's given to you. So if it works on the example files, it should be fine. Right. So non-Latin characters, don't worry about it. Is it possible to split a string based on tab spaces? Yes, it's possible. I would not recommend trying to do that. So in general, splitting strings in C is kind of complicated and annoying. There is a function that does it, but it's not easy to handle. So I recommend just going with for loops and just do it manually. It's easier. All right. Separate weight and term. Sorry, so what do you mean the second part? Sorry, which question? Can you repeat what the question is? Alexander. Yeah, so I did answer it. So just use a for loop, do it manually. So just go character by, so like I think the easiest way to do it is to go character by character, and then if the character that you encounter is a tab, you do one thing. If it's not a tab, you do another thing. Yeah, so like anything that compiles is allowed. I don't necessarily recommend doing it because it can be kind of more complicated than just straightforwardly using for loops, and like straightforwardly using for loops is also better kind of better for you in terms of practicing the fundamentals. With that said, if you want to use scanf, I'm fine with that too. Just a for loop. And yeah. And yeah, so like and I suppose, sorry, so like I should go back on that a little bit. So what I was referring to is like the question from before with the tabs and stuff like that. So that I think is easier to do with for loops. So certainly kind of converting the the weight to a number is, I would do it with ATOF. So like the float equivalent of A to I. You don't really need a realloc because because kind of the magnitude of everything is limited, right? So you know that the terms are at most 200 characters. So I'm having a problem with read in terms sec faults after successfully reading and properly formatting some of the lines of terms. And trying to strcpy the separated lines into the term, and also when I trying to modify the weights. So the answer is it could be anything, to be honest. What's true about sec faults is that when the sec fault happens is not necessarily where the issue is. It might be that the issue happened before. So what I would recommend is running the things through Valgrind and seeing which line Valgrind points out as the first problematic line. That should help with debugging, because some of the time the sec fault happens after the legal memory access, not right away, because you mess up the memory somehow, but that doesn't cause the crash. It's after, for example, like you mess up a particular pointer and then you try to go to the address pointed to by that pointer, and that is when the error happens, not when you messed up the pointer. So Valgrind sometimes will tell you, like, the first problem is on that line. It doesn't. So a sec fault corresponds to an error that was detected. So it's kind of, trivially, it's possible that the problem is before, just because like the problem might have been with a setup. It might be that the particular line that causes the crash is completely correct, or like it would be correct if the preceding code was correct. So sometimes the sec fault happens after the bug, not right away. So you can't check which part is the term and which part is the weight. What you can do is you know that the term comes first and then comes the weight, right? So think about like you're going line by line, and initially it's definitely the term, and then afterwards it's the other way. So first it's the weight and then it's the term, right? So like once you've started reading in the term, you know that it's not going to switch back to being the weight. What we're supposed to achieve in the autocomplete function. So the autocomplete function So the autocomplete function takes in the terms, and it takes in a pointer to answers, which answers are not initialized. So the result of running autocomplete should be that star answer contains the answer. Initially, star answer is just nothing. And then star n answer should contain the number of terms that you found that match the substring. Does that make sense? So it is the description of the variables, right? It's just that it's supposed to make it happen that the variables contain what the description says. Initially, star answer and star n answer do not contain the answer and the number of answers. So you're asking about two separate functions. You're asking about strcmp and str and cmp. So definitely it's possible to just use str and cmp. So just strcmp, if you're asking, can you do parts 2 and 3 with just strcmp without strncmp, which you don't need to write your own that exists in string.h. Then the answer is technically yes, but it won't be necessarily that easy. All right. Okay. All right. I got to go to my next thing. When will online lab 2 be out? I don't know. Hopefully next week. But to be clear, like online lab 2 was already submitted. So the grades, like when the TAs finish grading it, I guess. All right. Okay. See ya. Bye.